Okay, and so this question, kinematics of a win, gives you a real-world scenario where we had the 400-meter final in the Rio Olympic Games, and we had LaShawn Merritt, Wade Van Niekerk, and Karani James all running in that 400-meter race. I'd encourage you to have a look at the video of that race and see how it transpires. But it's something that we see in quite a few races actually, is this the profile of kinematics, or the profile of time, velocity and accelerations through a race, and how they change over time. So we often think that the fastest runner in a race is going to be the winner of that race, but in this one is a classic example where that's not necessarily true. So I'll just bring across here the web page that I've got linked to, and so what you can see here, it's an interesting graph that they've shown. This is basically split times, but it's inverted, so on the y-axis, so it's a lower split time at the top. So it's actually, it pretty much mirrors what you'd see in the velocity graph, where if it's going up, then the velocity is high, and when it goes down, the velocity is a little bit lower. So this is pretty typical of what we see of skilled 400-meter runners. Their velocity is building up towards the 100-meter mark. 100-meter runners, by the way, typically peak around 60-meter mark. The 400-meter runners usually peak a little bit later, but somewhere between the 50 and 100-meter mark. So the second split between 50 and 100 is obviously faster than their first split. And so they're building up this velocity. They usually peak around here, and then they're basically dropping through the rest of the race. And so what you might notice about Van Niekerk, the yellow line here, he had a pretty similar sort of velocity to the others after the first split. So he reached the 100-meter mark at a pretty similar rate, and he actually early on after that into the 150-meter mark had a lower velocity than Merritt. So at this point in the race, he wasn't the peak, but what he was able to do through the rest of the race was not accelerate, but to hold his velocity for longer. So he was decelerating through most of the race, but he was decelerating at a lower rate. Now I don't have the answers for the equations here. I'll post those up for the actual accelerations, but you can almost see from this graph here what the accelerations would look like. They'd be high here, and then you've got a negative acceleration or a deceleration through most of the race, and Van Niekerk was able to separate himself by having the lowest negative acceleration through the race. So hopefully that's quite an interesting thing for you to have there. In terms of a short answer question, if we ask that in the exam, then what we're wanting to get some key points out of you there. And so while Van Niekerk didn't achieve the highest peak velocity during the race, he did manage to maintain a higher velocity for longer, at a lower deceleration than the rest. And that average velocity, greater average velocity he had over the whole race, allowed him to achieve a lower time.